Alright guys, this lesson is about the properties of chords and tangents. One of the main principles we're going to be using is that if the chords are congruent, then the arcs that go with them are congruent. So here we have 116 degrees for arc AB. That means the remaining part of the circle, that's 360 minus 116, is going to be 244 degrees. Now that 244 degrees will be shared equally between arc AC and arc CB. So that means we'll have to divide that by 2 and we'll get 122 degrees. That means both arc AC and CB are 122 degrees. But specifically we were asked to find the measure of arc BC, and that is 122 degrees. So number 2. This time they gave us no numbers, but that's okay because each of these arcs are going to be congruent since the chords that go with them are congruent. So we can just take the 360 degree total and divide that by 4. Alright, 36 divided by 4 is 9. So this is 90 degrees. That means each one of these arcs is 90 degrees. But specifically we're asked for arc LM. So of course that's 90 degrees just like all the others. Alright, when it comes to circles and segments, there are 3 concepts that are closely related: diameter, perpendicular, and bisector. So what the relationship is if you have any 2 of these 3, you can assume the third. For example, if I give you a perpendicular bisector, alright, the way I show perpendicular is by putting a 90 degree little box right here. The way I will show bisector is by either marking these the same, or I could put numbers on them that are the same, like 5 and 5, so you know it's a bisector. So here I've given you a perpendicular bisector. If I give you these 2, you can assume that the third one is true. In other words, given a perpendicular bisector, you can assume that the perpendicular bisector is also the diameter. Alright, and normally you'll show a diameter with a dot for the center. Okay, so given a perpendicular bisector, we can conclude diameter, that this green segment is the diameter. Similarly, let's pick a different 2. Let's say we're given a diameter, that's the bisector. Again, you'll be given diameter by being given this dot right here showing the center. And again, to show that it's the bisector, maybe I'll give you these lengths, are 5 and 5. So if you're given a diameter that's a bisector, you can conclude that it's also perpendicular. So even though it's not shown, you can conclude that it's perpendicular. Okay, let's do the one that we haven't done yet. Alright, because again, given any 2 of these 3, you can conclude the third. So if I give you a diameter that is perpendicular, you can conclude that it's a bisector. So again, the way I show diameter is I'll put a dot. The way I show perpendicular is I'll give you this. So in this picture, I'm giving you a diameter that is perpendicular. So you can conclude that it is a bisector. So for example, if I told you that this was 7 and I put an X over here, you could conclude that X was 7 because these have to be the same. Alright? And notice that would not necessarily be true if I only gave you that this was the diameter, but I didn't tell you that it was perpendicular. then that doesn't mean these two are equal. Alright, so this is going to come up again and again. That's not what I wanted. So when you look at problem number 3, in terms of the three words, diameter, perpendicular, and bisector, which two of these are we given in this picture? Well, this dot means that we're given a diameter. This 90-degree box means that we're given perpendicular. Therefore, we can conclude that it's a bisector. In other words, it's splitting this in half. So if this is 11, then this will also be 11. So we're supposed to find the length of QS, and that would be 22. Alright, that's not degrees or anything, it's just 22. But keep this in mind, it comes up a lot. So looking at number 4, we can use our knowledge of inscribed angles. Okay, when you have an angle whose vertex is on the circle, it's half the arc. So half of 130 is 65. Actually, scratch that. I don't care about that. We're supposed to find the measure of arc AC. So that's this over here. So we'll do like we did up here and simply subtract from 360. So if I do 360 minus 130, that's going to be 230 degrees. Since these chords are congruent, that means the arcs are congruent. So I will just take this and divide by 2, and that will give me each one. So dividing this by 2 is 115 degrees. So that means this is 115 degrees, and this is 115 degrees. But they asked us for the measure of arc AC. So 115 degrees. Okay. This is we have a perpendicular bisector, and so that's if these little chords are congruent, then also the arc, the pieces of this arc are congruent. So if this is 40 degrees, this is also going to be 40 degrees. So arc PQR is going to be 80 degrees. Alright, it's just the total of those. Alright, for number 6, we're supposed to find the measure of arc KLM. KLM, so that's from here through here to here. Okay, we're finding the measure of this arc. Okay, well, let's take it piece by piece. Well, actually, let's not take it piece by piece. Let's just do the whole thing. So again, KLM is this green arc right here. But we're already given the rest of the circle. Okay, we're given the fuchsia arc. Okay, so the fuchsia arc is the 38 and the 142. So all we really need to do is subtract from 360, and that will give us the KLM that we wanted. So if we do, that's too big. If we do 360 minus 142 minus 38, let's see what we get. We get 180 degrees. So that means arc KLM must be a semicircle. It's 180 degrees. Alright, for number 7, we are supposed to find the value of x. Well, remember the three words, perpendicular, bisector, and diameter. If any two of those are given, the third one can be assumed. So see this dot? That means we're given diameter. See this box? That means we're given perpendicular. that means we can conclude bisector. Okay, we can conclude that these two are congruent. I need the space. So specifically 12x plus 7, this piece, should equal 3x plus 16. Subtract 3x from both sides, gives you 9x plus 7 equals 16. Subtract 7 from both sides, that gives you 9x equals 9. And divide by 9. That gives you x equals 1. Alright, here's a new theorem. If the perpendicular distance of a chord is equal to the perpendicular distance of another chord, then the chords themselves are congruent. Okay, if the perpendicular distance is congruent, then the chords are congruent. So see these marks? That means the perpendicular distances are equal. That means the measures of these arcs are equal, so that means that 3x minus 11 should equal x plus 9. So I would subtract x from both sides, and that's going to give me 2x minus 11 is equal to 9. But then I would add 11 to both sides, so that is going to give me 2x is equal to 20. Then divide both sides by 2. So x is equal to 10. Number 9. Number 9 is back to 3 little words: diameter, perpendicular, and bisector. Given any two, the third one must be true. So here, see that dot? That means we're given diameter. See that? It's perpendicular. So we're given a perpendicular diameter. What of it, you say? Yeah, if we're given a perpendicular, check, diameter, check, it must be a bisector. Okay? In other words, these two must be congruent. In other words, 9x minus 3 should equal 7x plus 5. I would subtract 7x from both sides to give us 2x minus 3 is equal to 5. Then I would add 3 on both sides. So 2x is equal to 8. Then I would divide both sides by 2. Alright, so x equals 4. Alright, again, if the perpendicular distances are equal, then the chords themselves are equal in length. So that means that these two chords must be equal length. So 13 plus 4x should equal 6x minus 5. Anytime I see x on two different sides of the equation, I want to get them together. So for example, I might subtract 6x. So that gives me 13 minus 2x is equal to negative 5. Then I will subtract 13 from both sides. So that's negative 2x is equal to negative 18. And then I will finally divide both sides by negative 2. So that gives me x equals 9. Alright, so this is sort of the reverse. Before I was saying, hey, if the perpendicular distances are equal, then the chords must be equal. But another way to look at that is that if the chords are equal, that must mean that the perpendicular distances are equal. So see how these chords are both 12? Alright, ML is 12 and JK is 12. If the chords are equal, then that means these perpendicular distances must be equal. In other words, 7x minus 10 should equal 3x plus 6. X is on both sides, so let's subtract to get them together. So that's 4x minus 10 is equal to 6. Add 10 to both sides. So 4x is equal to 16. And finally divide both sides by 4. So x is equal to 4. Alright, well, this doesn't use really special properties. These are both radii of the same circle, so of course they should be equal length. So 14x minus 9 should equal 9x plus 21. I would subtract 9x from both sides, and that's going to give us 5x minus 9 is equal to 21. Of course, then we add 9 to both sides, so that gives us 5x is equal to 30. Alright, it might be time to divide. So that's going to give us x is equal to 6. Alright, error analysis. We are supposed to explain what is wrong with the diagram. Let's take a look. Well, the perpendicular distances are equal, you can tell by the markings. And if the perpendicular distances are equal, then the lengths of the chords should be equal, but they're not. So that's a problem. So here you go. If the perpendicular distances are equal, the chords should be congruent. Yet one is 18 while the other is 16. Kapow and shapow. Okay. Alright, when you have two tangents converging at a point outside of the circle, then the lengths of these tangents should be equal. So that means 3x minus 6 should equal x plus 10. Alright, let's get the x's together by subtracting it. That'll be 2x minus 6 is equal to 10. Now we add 6 to both sides, so 2x is equal to 16. And finally we divide by 2. So that gives us x equals 8. Okay, same thing here. So these, when you have tangents converging at a single point, they should be congruent. So 4x plus 2 should equal 2x plus 8. Subtracting 2x from both sides gives us 2x plus 2 equals 8. Subtracting 2 from both sides gives us 2x is equal to 6. Then it's time to divide by 2. So x is equal to 3. And that is the last problem in this lesson. I hope it was a helpful lesson for you. I will see you on the next video.